In this lecture, we are going to discuss about weighted binary code BCD. BCD stands for binary coded decimal. So, what are the digital codes and what is the requirement of digital codes? Basically, the numbers, letters, or words can be represented by a specific group of symbols, and the group of symbols is called as code. So specifically, if we talk about a computer works on binary. So everything we represent in terms of binary, we store in terms of binary, as well as we transmit everything in terms of binary. So if the numbers, letters, alphabets or special characters, they are represented in terms of bits. So digital codes are called as the binary codes. And what is the purpose of digital or the binary codes? That is to enhance the security. So if we transmit the information in terms of codes, obviously they are more secure. And the another benefit is, let's say if we transmit some information, so while transferring the information, there may be chances of introduction of noise in the channel. So on the receiver side, if we have the digital code, then we can easily detect the error if there is some error, as well as we also correct that particular error. So there are many error detection and correction codes that we can apply while transmitting the information, so that on the receiver side, if there is some error, so that can be easily detected as well as corrected. And the digital codes are comparatively more compact also. So there is the saving of space also, saving of bandwidth also. So these are the benefits of digital codes. So binary code can be of two types, that can be weighted binary code or the non-weighted or unweighted binary code. So basically, what is the difference between weighted code and the non-weighted code? In the weighted binary code, each bit in the binary that is assigned with a particular binary weight. So basically, like we have discussed that if we talk about the binary, so let's say example is 1001. So we have already discussed this point that each particular bit is assigned with a particular weight. Like this is the least significant bit that is assigned with the weight 2 raised to power 0, and the next consecutive bit is assigned with the weight that is 2 raised to power 1, and the next consecutive bit that is assigned with the weight 2 raised to power 2. So basically binary weights are in the increasing order as we proceed from right to left, that is from least significant bit to the most significant bit. And the example of weighted binary code is BCD code. BCD stands for binary coded decimal. And what are the non-weighted binary codes? In the non-weighted binary codes, there is no specific weight assigned to the bit position. And the example of non-weighted binary code are XS3 code and the gray code. So here in this lecture, we are going to discuss the weighted binary code, that is the BCD code. BCD stands for binary coded decimal. So here each digit of the decimal number is represented by its equivalent 4-bit binary code. And as we are representing every digit in terms of 4 bits of binary, so 4 bits of binary, they are assigned with the 4 weights as per their position from MSB to LSB. The MSB bit is assigned with the weight 8 and the LSB is assigned with the weight 1. So basically BCD, that is a weighted code as each bit is assigned with a particular weight as per its position. and they are also popular as 8421 code because weights are in the order 1, 2, 4 and 8. 1 is the weight assigned to the least significant bit, 2 is assigned to next consecutive bit, 4 is assigned to next consecutive bit, and the 8 is the positional weight of the most significant bit. So remember that BCD code is also called as 8421 code. So how to represent the decimal number in the terms of BCD code? Like we have decimal numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the valid decimal numbers in the BCD are 0 to 9. Remember this. So that means 10, 11, 12, 13, 14. These decimal numbers are invalid in the BCD. So 0 is represented similar to the binary in the BCD. In terms of 4 bits, binary and BCD are same, that they are represented by 4 zeros. The 1 representation is also same in the BCD and binary, 0001, 0001, and 2 is 0010, 0010. Same is 3, 0011 and 0011. Then 4 will be 0100 and 0100. 5 is 0101 and 0101. 6 is also same, 0110, 0110. 7 is 0111, here also it is 0111. 8 is 1000 in both the case BCD as well as binary. 9 is also same, 1001 and 1001 because positional weights are 1, 2, 4 and 8. So till 9 both the codes are same, binary code as well as BCD. But if we see any decimal number that is more than 9, so representation changes. The reason is after 9 the decimal digits are invalid in terms of BCD. So that means for 10 we have to represent the BCD code of it by putting each decimal digit in terms of equivalent binary of 4 bits. Like here we have 2 digits, so we write the BCD code or you can say the binary of 1 in terms of 4 bits separately and the binary in terms of 4 bit for 0 separately. So if we write the binary equivalent of 1 in terms of 4 bit, that will be 0001, and for 0 it will be 0000. But if we talk about binary, so this is considered as 10 and the equivalent binary is 1010. So that is the basic difference here, that in the BCD each digit in the decimal is considered separately for writing the BCD codes in terms of 4 bits of binary. That's why this is called as the binary coded decimal. Each decimal digit is coded in terms of binary in terms of 4 bits. So for 111 need to be written separately and this one need to be written separately in terms of binary in terms of 4 bits. But for binary 11 is represented as 1011. So 12 will be in terms of BCD, 1 is written separately and 2 is written separately. 0001 is 1 and 0010 is 2. And the binary equivalent of 12 is 1100. For 13, 1 is written separately and 3 is written separately, and in terms of binary it is written as 1101. And for 14, 1 is written again separately and the 4 is also written separately. But for binary it is 1110. So here if we are representing 15, so again 1 is represented separately and 5 is written separately. But in terms of binary it is 1111. So basically if we are converting decimal to binary, that means we have to go by repeated division by 2 method, that already we have discussed for the conversion. But for the BCD conversion 0 to 9 the decimal values, they are represented in terms of binary, in terms of 4 bits, but any decimal number greater than 9, so each decimal digit is written separately in terms of binary, in terms of 4 bits. For example, if we take the BCD code conversion for 95 decimal value that we need to convert to BCD. So we take 9 as a decimal digit separately and 5 as a decimal digit separately. And for 9 we have to write binary equivalent in terms of 4 bits, that is 1 0 0 1. So that will be its BCD equivalent. And for 5 we are writing separately, that is 0 1 0 1, that is its BCD equivalent. So for complete number 95 in decimal, we write the BCD code as 9 code is 1001 and for 5 it is 0101. These are the references I have used. Thank you.